So PV 101 basics. All right, so here we go. Photovoltaics. Photons from the sun. Voltaics. Volts. Okay? So photovoltaics. I had to learn that word quite a bit 3 years ago. I had to take some time, because everyone's like, oh, photo, how do you say that? But no moving parts, relatively simple technology and design. Very little maintenance. In our industry, say you set it and you forget it. You really don't have to touch this stuff anymore. I mean, we monitor it, we set bandwidths on it. If it ever drops, we go out there and we troubleshoot it. Most of your failure points is the inverter. So imagine you having 4,000 of these in one of these, and this thing goes down. Well, that's pretty easy. I can just take this out at night, put a new one in. So not a whole lot of risk on the side of all those modules. The modules is about a 13 to 15% failure rate. But those are easy to pull off. Every module can be by itself. So you can just unhook it, pull it out, stick another one back in, pull it in, punch it together. So the downtime on the systems there's really no downtime, maybe a day or two. So what happens is you got the sun's energy, which is direct current, drops down on this module. This module pops off an electron that's already sitting in there, pumps into an inversion, the energy inversion, the inverter, which is this system right here, this little guy right here. That changes the DC current into an AC current, which runs all our lights. And the grid is like this huge, massive, rotating system. And you've got to synchronize into it. So these inverters have a really tough job of changing that from DC to AC and then pushing it into the grid and synchronizing how the grid works. Back in the 50s, when we started industrializing, we started building out roads. In 1957, we had our Highway Act. We started building more suburbs. Okay, the energy company's like, okay, well, if you push a direct current, eventually that direct current drops because just there's no more power. Or unless you have these, like in 1930s when Bell South, they had, it's called the PV effect. They had these telephone lines, and they were direct current. Well, they would put a solar module on every telephone pole. And what that did is it popped the current back up so they could send it further out. Well, back in the 50s, these guys were like, well, we're going to go AC or DC. Well, we decided to go AC because we can whip this current up further. Because we were starting to build out our cities and our suburbs and things. So we have to take this DC and we have to put it back into AC. So you can do a number of things with that. You can store it with battery storage. You can use it as energy. Say your house is on and you've got lights and clocks in the refrigerator. Or you can push it out, or if you're not using as much energy, you can push it out onto the grid. And you can sell it. So the way I look at solar power is people are like, well, what does that really mean? I go, imagine having a cornfield on your house and selling corn every single day to the utility. And that's what we do. We sell this commodity out to the grid. This is a power plant, no matter how big it is. It can be 3 modules, 1 module, 4,000 modules. These are power plants. These make a commodity, a kilowatt hour, that's needed every single day in our lives. Imagine our cell phones, our computers, everything we have that kind of controls our lives now is all through electricity. So this is kind of breaking. It's not a big, huge rocket science. The real science is kind of in the cells. These guys, that's where they kind of do a lot of the capturing, and then obviously into the inverter. But it's pretty simple. I mean, we all could probably take a class in a number of hours and learn how to install this thing. So it's not really, like I said, rocket science when your installation. I mean, the technology obviously is, but it's the point now where, like I said, it's all about scale and all about bringing price down. Next slide. So this is the solar module. So here we go. So this is we'll just work this guy. So this is like a 230 watt module. Like I said, it's made of aluminum, glass. It's all benign. You can take this out, recycle all this. You have usually 6 cells by 10 that make it up. What they do is they grow ingots, so they grab sand and they heat it up and they grow these ingots, these big, long, huge tubes, and then they mix them in with boron, which is kind of a semiconductor material, and then they take this really small, tight blade and they slice this stuff up into wafers, and then they heat it up, they do some more inking to it, and it becomes semiconductivity. And then they're very, very brittle. So when you see these manufacturing plants, a lot of it is all like machines that do this. So you'll see you'll have this stack of cells. This machine comes over, grabs it, moves it, drops it, grabs it, moves it, drops it. And there's a guy just watching that every single day. Not really a fun job. And then it moves it over, and then it sets all these cells up. And then it sets it on the back sheet, It then goes into a cooker and it cooks these things together, it laminates it, and then they put the glass on it, they slap on the side, they put on this junction box on the side, on the back, and then they test it, and then that's out the door. So it's not a whole lot of manual labor that goes into building a module. The 25-year production warranties. So when you buy this stuff, they'll operate at, used to be the industry standard was in the first 10 years it operated 90% or better of the nameplate. And after that, from years 11 to 25, it operated 80% better. Now you're starting to see module manufacturers will have linear degradation. So on any module, you'll see where once you install it, it's interesting. It's about a 3% drop, and then every year it drops about 0.5% of production. So if your energy costs are going up 5 or 10%, and your production level is only going down 0.5%, and you're getting a huge benefit of that. The workmanship usually on these, sometimes even 5 years, 10 years. They're sturdy. You know, you really can't. It's tempered glass. Hail doesn't do anything to these. There's a guy, Dennis Pomerantz. He's been installing solar for 20-some years in Iowa. He's never pulled a module off the rooftop that hail damage. These things are always usually pitched, so hail just usually pops right down. You don't really want to stand on them though, but they are strong and they can take a beating. And they're not too heavy. They weigh about 40 to 44 pounds. And like I said, they can be installed anywhere. Next slide.
The real home run is, as Tim said, it's got a 25-year warranty. So what does that mean for you? You make the investment and do this installation. That's 25 years from your installation that you've locked in your energy costs. You know, you may add a new refrigerator or an additional flat screen TV or something like that over time, or build an addition. But in general, and you can add on to your install, but you've locked in your energy costs for the next 25 years.
Yeah, so when you buy a system, that's your energy cost, because you know the sun's going to come up pretty soon. And if it doesn't, then there's make it really cold. All right, so like I said, it's about 60 solar cells. You got a cell, then you get a module, and then within these modules, you'll have an array. But you also have a panel too as well, which I'll kind of show you. They've got a little panel side on that too. That's kind of how these things are built. And you have other different technologies. You have like SIGs, which is a kind of a lower efficiency. You have thin film, which that gentleman right there is holding. He's got a small little thin film module right there. A little bit good technology. There's a company called Cylindra that was coming out on Bush's plate, and it kind of got stuck at the top when Bush moved out and Obama came in. And the problem with that technology is when you're competing against rooftop gets your most power, right? The side of the building, the sun's up here. Well, thin film technology, that can turn on with not a whole lot of light. So as the sun comes up on a crystalline module, you'll see it ramp up. As we start rolling towards the sun, the bell curve will just keep ramping up, and it hits the peak, and it ramps back down. Thin film technology, once that sun comes up, it turns on, and it doesn't ramp up very much because it absorbs the infrared. So you'll see a lot of that technology more on side of homes, and that's where Cylindra probably should have put their money, and their type of application was on more on side. But they have an interesting cylinder, and when the sun moves, like eventually on the sun, when I come up on the east here, as I start rolling, this energy pops up, the production pops up because the sun's moving and it gets more intense. Where Cylindra was a cylinder, so their whole idea was, well, if I'm round, and no matter if the sun's up over here, I'm always hitting the same amount of silicon all the time. And they have little spaces between them, and you paint the roof white, so you get deflection, you get ambient light underneath. So they were saying they were always on. But they didn't produce as much power. And when they came out in the market, they came out right before the recession. So modules used to be $4 a watt. Okay, Cylindra came out at $3.75 a watt. Recession hit, the Chinese looked around and said, we got all these modules sitting around here, we need to cut prices. They cut prices 50%. So imagine you coming onto a market in a recession, for one, and your competition that you were going to beat by 25 cents a watt, all of a sudden drops 50%, and now you're $1.75 a watt more expensive. And you're producing less, and you're new technology. So a lot of factors went into involved in that, and why that technology didn't scale fast enough. Plus, they weren't really focused on a lot of these other foreign markets. They were more United States, and as you see on those graphs, and what we're seeing is the United States, we haven't been putting any type of solar in compared to some of these other countries. So there are a lot of challenges, and that's why that company kind of went under, was They were too expensive, the technology was new, it wasn't as efficient, it wasn't as powerful. Excellent. So, this is kind of an array. This is that Mount Pleasant array. So this is, so what we have is you have your cell, and you have your module, and all these are in series, okay? So there are 13 series, 13 modules in a series. And these are all, you have a negative side and you have a positive side. So all the energy gets funneled all the way up into, up to the positive, and then it gets, and all these old black wires, they weren't all interconnected yet. This is just kind of when they set them up. You want to set them all up first, then you come back in and you plug and play. And they both each have, and they're not really hard, they both have a female end and a male end. So you really can't mess them up when you install. It's pretty easy to do that. And then all these come together into a combiner box, and that combiner box then is home ran into an inverter. And so this kind of shows you, this is one of the lowest cost of installs. If you look at the racking is these little S-clamps that hook right onto the seam. So when we look, like for an aisle right now, we have really low energy prices. So what we try to look for is low cost of install. And this is the lowest cost. One, not a lot of racking material, and two, this stuff goes up really fast. I mean, you just pop down these little hooks on the single standing seam, and you lay the module down, pop the other ones, lay the module down, it goes up really fast. These guys are putting about 100 modules a day, once they got the hang of it. So, pretty quick. Here's your inverter, all right? So this is kind of where all the work kind of gets done, where you get changed from the DC to the AC. It's got a DC disconnect, so as the DC home run comes up into the inverter, you've got a disco. Now on this guy, we don't have a disco, I don't put a disconnector on here. This is a real small, this is only 700 watt. This guy is more like a 5,000 all the way up to an 8,000 watt system. So when you have a 5 kW, that sun comes up, that means there's 5,000 watts coming off that system, non-stop. A lot of power coming off these. You just can't shut them off. I mean, once light hits this, these things are on. They're active. So, you know, these inverters, one of the coolest things about the inverter is back in the 60s when we started to understand, when we were out in space, that there's a perfect voltage that you have to be at when, no matter what the intensity is. All right, so when we were flying, when our satellites were moving around, they're not always in the perfect alignment, right? But still, light's hitting that. So they call it maximum power point tracking. So these inverters actually have these smart parts in them that find that voltage, and it plays right in between before and after, because if you hit the voltage, you'll move it. So now it actually made these modules, instead of things tracking, you can actually set them flat, and these inverters will always track what's the perfect voltage amount, or right in between what the perfect voltage amount, so you get the most benefit off your module. So a lot of advancement that's happened into this, and they've gotten smaller, they've gotten more efficient. This is about a 90, I think it's 96% efficiency, maybe 97 on the peak, 97 on the peak efficiency. So yeah, inverters, and this thing will sit right next to your meter. I mean, DC comes in, inverts it, comes up one side, inverts it, pops out AC the other side, and then you have an AC disconnect. So if there's ever a problem on the grid or near your house, the utility can come right up and just shut the whole system. So that's kind of an inverter, and they can be different sizes. It might be big. Oh, so that's what they look like. So there's 3 inverters right there. So not those. This was on a 17 kW. So I think those are. I think there might be two 5 kWs on that, and then a 7 kW inverter. Yeah. So that's kind of what they look like. They're heavy little guys. And this thing, how much does that weigh, Alan? What do you think? 60 pounds? Yeah. Yeah. I mean, they're not light. And then you get the ones you just saw, like those guys. Those weigh about 140 pounds. They're heavy duty little guys. And they sit out and they'll just run all day. And the interesting is, you know, as clouds move over, the clouds move over, clouds move up, so they're constantly up and down all the time. It's kind of neat when you see the bell curve, and all of a sudden you'll see it drop, and like, oh, the clouds must move over, and then boom, it pops back up as the intensity returns back on the model. That's a big one. That's like 100 kW. I think it's like 4,000 pounds. That's the one that's down at that Mount Pleasant REC. Pretty big. And they operate between 295 to 600 volts DC. A lot of power that goes into these things. And they try to mitigate a lot of risks on this, where they'll have like, they call them cage, they call them, what do card cages, where if one goes down, all they do is they pull out the card cage and put a new one in. And change over on the stuff is really, really fast. Real reliable. We've had inverters change it from AC to DC to DC to AC to AC to AC, DC to I mean, throughout the last 40, 50 years. So inverting energy is not really new to the game. They have 10-year warranties on them. You can buy extension of 20 years. We usually see the inverter go out about 15 years. So, distributed residential. So, small photovoltaic systems that are typically on residential. So in Iowa, we do about 10,600 kilowatt hours on average on our homes. So if you install a 5 kW system, you're probably going to offset about 75% of your energy on that. Some people might do more than that. Some of the houses we've been looking at lately, our house has gotten bigger. And it's interesting when you see, like, back in like 2004 or 5, you can see this huge spiking pole. Is because back in the housing boom, back in the early 2000s, our homes got bigger, which absorbed more energy. And the plasma TV came out. So it's interesting, you see these lines, and boom, all of a sudden there's this huge spiking pole. It's pretty wild. I don't think we have that slide. Let's see here. So it's becoming obviously more cost effective due to utility rebates, tax incentives, and lower equipment costs. So back before 2008, when we passed the stimulus package, you used to only get 30% tax credit on the first $2,000 of your system. Now it's on the full gross. And if you have an incentive, then it's off that net amount. On the commercial side, you get, no matter if you have an incentive or not, you get the 30% off the gross cost, and then you get depreciation as well. So we'll go into some of that as well. Next slide. So yeah, so that's kind of what a system looks like on your house. And I think there's a picture maybe coming up here. Yeah, this is out in Arizona. If you guys can you see the little shadowing effect? So my old man had a friend of his. This thing is still working. This is a solar hot water. Thermal. This thing was installed in like 1970, and I asked the guy, "Is this thing working?" He goes, "Oh man, it still works. Still works." But he was about 70-some years old, and it's pretty cool to see like these older generations get fired up when they put solar in, because they're like, "Yeah, I remember when this came out in the 70s, and now I can afford it, and now it's doable, and a lot of sun out there." But you gotta be smart about how you install. First thing I walked up there, I was like, "You got a problem up here?" I was like, "What's that?" I go, "You see your dish right here? That's a shading issue." So if all these are in strings, and if I shade a module, that'll knock out that whole string. So I was like, you might want to move your dish because you're not getting as much production because you're going to knock that out. Yeah. So every time you have these in strings, shading is your worst enemy. You can have small microinverters that fit behind each module, and that will make each module its own AC module. But you got a lot more inverters as well, a little more expense on cost as also install. I mean, if you install just one of these, it's not a big deal. But when you have we just did a job the other day, 160 little inverters behind 160 modules. So it takes a little longer to put all that stuff in. Instead of just plugging the modules together, you got to hook up the little inverter that sits right behind here, plug all that in, you got to ground it. It's a lot more. But if you're in an area that gives a great incentive, or you're in an area that's got a lot of sunlight, even more so like in the Southwest, it might be worth that extra. And especially if you're paying more for your energy costs too. It might be worth that extra cost to put that in, because then every one of these modules, if they had a single inverter, would be producing the best it can. When they're in the string and they're all combined, they'll all produce at the lowest producing module, because energy goes to the least resistance. So when you install these, when these come off the line, they give them a nice little flash test, and they'll have a number on them. So when you install these, the installers have to know that if they're in strings, you got to put those numbers kind of close together, because then they'll all be operating pretty close. If you had one that was like, say these are 235 watt modules, if you had a lot of them doing 238 or 234 or 230, you had one that was doing like 225, they'll all operate at 225. And it's interesting when you do there's a system we did in Colorado, and you can see like they'll have different color codes on it, how much that module's producing, and you can see the difference in the modules. Because when we make stuff, none of everything's the same, it's not all perfect. So then you have a lot of, when you have a poly instead of a mono, there's different efficiencies. So that's what a residential system looks like. Commercial scale, you got electrical systems, typically commercial, business applications. This is kind of where PV helps PV, because when you're buying bigger systems, then these manufacturers know that they're going to make more modules, so they're going to price them. Your typical commercial applications, about 25 kW. all the way up to like 100 kW. In the state of Iowa, the biggest array right now is Luther College. They have a 280 kW ground mount. There was a 200 kW that's on top of a parking structure in Iowa, just down the road here at the end of Madison Street, with a 51 kW. That powers 4 electric cars playing right now. Has a capacity to power 35 electric cars. When you start powering the car with solar energy and electricity, the savings is massive, massive. And that's kind of where we need to get to next, is not just fighting and competing against a kilowatt hour for a home on the prices that we're buying kilowatt hours off traditional, but also oil prices. I mean, we're working on this little job right now where we've got these little electric MIVs, they're Mitsubishi electric vehicles. Take 16 kilowatt hours to power this, well, you pay 10 cents a kilowatt hour, right? These cars will go 60 miles, right? So it costs you $1.60. So if it was equivalent to what a 20-gallon gas tank cost you, and you're doing 600 gallons a year, it's about almost $3,000 a year. This electric car on the same type of capacity will cost you $250 a year to travel. So you're thinking, wow, just multiply that across the board, how much savings that would be. So when you get into, and especially then when you add solar to it, the savings goes up even more. And you're talking about power that you don't have to send Marines out to anymore. You have to send, you know, boats and all this wild stuff that we're doing right now to protect, you know, that resource. And we get it for free. Next slide. And then so this is kind of like a ballasted system. So there is a job we just did in Danville, Illinois. A lot of times when you're on a flat roof, a lot of people don't want to do penetrations because then you have issues. You know, you have water. A lot of people don't want water coming down on their building. So this is an application that sits up on top of your roof and it just ballasts and sits. And they're all connected. This is a really neat design, really low cost, low materials, and really fast install. I think they installed this thing in like a matter, I think it was 21 kW, and you'll see a picture of it. They installed that, I think, in a matter of like 2 weeks. First install these guys did over there, and I was like, how'd it go? Because I had to go over and do a small little presentation on the maintenance and all that. And like, oh man, it was easy. They're like, sweet. So we'll keep doing it. But this is I mean, back in the day, you should have seen some of the racks that we used to have. It was pretty kind of embarrassing. But as this industry grows, you're going to see more and more like, you know, design and more engineering that comes into this. And that's what's really making this industry become a real industry. Is now the engineers and the designers and the electrical engineers are in this industry making this stuff perform. You know, the guys that wired this building, they didn't engineer it, they didn't design it, right? They just got a plan set, they got the material, and they showed up and they put it in. Back in the 70s, the electrical contractors were kind of designing all this and trying to throw everything together. So there was a very fractured market. We're seeing a lot more streamlined market now. The only thing with the ground ballasted system is the tilting can't be as big. Because once you tilt it too much, you get wind that can pull it off. So your tilt is a lot less, anywhere between 10 to 12 degrees, which means you're going to get less production instead of like a 20 to 30 degree. And there's ways that you can build, which you'll see on one of these slides that we did on a flat roof that we mechanically attached and pitched to 30 degrees. Next slide.
The other benefit to this is if you are in a situation as a commercial property owner and you know you're going to have to replace your roof in a few years, but you want to get started with solar, this is a great application for that. And then they're pretty easy to remove and replace your roof and then come back in with the same of the roof.
But you want to match up your, if you have an old roof, you want to redo it and then put solar in. You don't want to, like, this thing's making you money every day. So if you take it off and it sits for 3 weeks, it's not making you any money. So when you look at an application, you got to figure out what your risks are, what's involved in, you know, roof orientation, and other aspects that are involved in when you're looking at rooftops. Because we haven't been designing our buildings to install solar. You got venting, you got HVAC units, you got big parapets, you got all these things up there that can, on retrofits, it makes it very challenging. I think so. That's what that looks like. So all these are in strings, each one, and then there's a combiner box way up there at the top. And it shoots over to, and they have another array on this side, and then it goes into a home run, drops off the back of the building, goes down to an AC disconnect, pumps into the building, and then shoots into the switchgear.
So you said that's Illinois?
Yeah, this is up at Danville College in Illinois. Pretty neat little install. Then you got your ground mounts. You know, this is kind of what I see the farmers getting into. I mean, we're seeing a lot of this in Germany, like I said, in Italy, Spain. Huge, massive fields of solar. And you know, like I said, you know, not a whole lot of risk. I mean, obviously tornadoes, maybe harvesting energy, free energy every single day. And we've got the opportunity here in Iowa to do this. I mean, if every farmer carved out 12 acres, they could put in about 2 megawatts of power and sell it out to the grid. You know, and you're thinking corn prices, you know, they're at $8 now because of our drought. You're thinking, okay, even at 200 bushels at $8, so just say $10, you look at $2,000 per acre. Well, I need 6 acres to do a megawatt. So 6 acres times $2,000 is 12 grand in corn. But if I had a solar bank, if I had a solar field at 6 acres at a megawatt, and I'm selling back at 10 cents, that's $130,000 of revenue stream. With not a whole lot of risk. Think about it. You know, and that's at 10 cents. That's what all of us are buying our energy for right now. And we're not talking about peak demand. When you get into peak demand, our energy is more expensive. Because those peaker plants that are all out around us now, all those natural gas plants, they only run 20 to 30 times out of the year. And the utilities have to make their return on their investment, right? Well, if you're only selling your commodity 20 to 30 days out of the year, and you need a return, how expensive does that commodity need to be? Where solar comes in, solar wipes out that expense. Solar really happens at the peaks. Because what makes the peaks? The sun. So solar, when we start getting to pricing, you know, no one really talks about how important solar is on a peak demand. Because now we're burning even more. We have to kick on these natural gas plants. Because on a coal plant, you can't ramp it up and down. It's just, coal plants, you got to think about it, just runs non-stop all the time. Baseline energy. All of a sudden, when the earth gets warmer, and all our air conditioners kick on, that's more power that needs to go to the grid. Well, to fulfill that, we need to have peaker plants. Well, solar, all of a sudden, just eliminates those peaker plants. So, ground mounts, real good. These can be adjustable as well. As the sun, as we tilt, we tilt about 1 degree a day, either away from the sun or towards the sun. So, you can imagine a farmer, as it gets later in the year, going out and just adjusting every array to tilt even higher to get more production. And then as the summer comes, tilting it back as the sun gets higher and creating more yield. Next slide. So that's kind of what a ground mount looks like. This out in near Canyon City, Colorado. A lot of sun out there. Not that big, but a lot of sun. Kind of cool installation. And then you got utility scale. Like I was saying, Mid-American bought into a 500 megawatt power plant solar power plant out of New Jersey. That's like 4,000 acres of solar panels. I mean, imagine that. Massive. And we're starting to see development like that. I mean, the pipeline for these system sizes of being this big is fairly robust. There's a lot of systems that are being built right now or in the works of being built. A lot in the Southwest. Because they have to supply, they're moving more into renewables. So for them to do that, and utilities, they want distributed, but they also like to kind of own their own power as well. So you start to see a lot more utilities in this stuff. Okay, next slide. This is kind of a small utility. It's more of a community utility. It's a 750 kW in Illinois. In the back there's 4 diesel generators. They installed them, I think, about 2 years before they installed these. And the EPA came into them and said by 2014 you're going to have to shut all this down because they're carbon intensive. So one of these systems actually offsets one of those big generators. So this kind of shows you what an application can be. This is a sunny wet box. This is kind of where we monitor everything. So once you get the system up and running, you've got to dive into this guy. He talks to the inverters and then eventually grabs all that data from the inverters and sends it out to a platform that's ran by either SMA or whoever your white box manufacturer is. They have these little programs where you can have your own little portal. You can jump on every day, you can put it on your cell phone, and you can just look up and see exactly how much power you're making, how much money you're making. So pretty neat. Now that's the really neat thing about one of the neat things is that now we can actually monitor this stuff. Back in the 70s, there was no such thing as internet. Well, there was maybe the military, but not for us. So now, I mean, how many people can go up to Mid-American and see how much power they're producing for a line? You really don't understand. You really can't see that. And as we become more smarter on our grid, these things will become a lot more valuable. And understanding peak demand response, peak shading and things, where the utility can then understand how much power is being generated in the distribution area, so now they don't have to send as much power. So that's what that looks like, just hooked up. So you have an inverter cable, and there'll be a cable Cat 5 that pops out of this guy, runs all the way up into the SMA box right here. This will filter data, and then it jumps into another Cat 5, and runs all the way up into your router, and then that pops pops into a server program that the manufacturer has, and then you can jump on there, you interconnect it, and then you start building your graphs out. You can demonstrate all kinds of different ways to show how much power you're making off your. I was trying to get a picture of that, of what that looks like. Okay, then just so off this inverter and off your AC disconnect, it pops right into your. And everybody has one of these. That's your main service box, and it pops in. So when we're looking at installing, we like to see empty spaces. This is a bus bar right in here. So you look at bus bar spots, and so we'll get an idea of how many voltages this thing is. Is it a 208, 240, which is your homes? Is it a 480? So we'll design these systems on certain inverters that need to be at certain voltages ranges. And so once we go out through the DC, for the AC disconnect, we pop into the main service box, and that either goes into your house or it goes out to the grid. And then there's your meter, and then your meter starts spinning backwards, which is what we all like to see. It's pretty cool. This is an electric meter, so you don't get the kind of effect of that. And so when you install these, the utility will come and they'll give you a bidirectional meter. So think about as you're pulling energy, you're pushing energy out, and then they net it at the end of the month. And if you have more than what you bought, then they move it into the next month. When we design these systems, we always design them to push out less than 100% of what you're pulling. Because once you go over 100%, then the utility buys it at a low cost. Buys it like 2 cents, or in Alliance territory, you buy it 6 cents. Where if you sell back at what you use, or just under what you use, then you can sell back for the retail rate. And there's discussion about how net metering is disadvantaging for people that don't have solar, but when you start looking at the type of costs and the type of benefits of solar to the grid, it kind of eliminates that discussion because it's free, it's clean, and you distribute it at the distribution area. You don't have to send it all the way in on those big expensive wires. It takes a lot of capital to build out. Cost of a PV system. All right, cost of electricity comparison. So you got to figure out how much your cost is compared to conventional power. So we'll get your last 12 months of utility bill, and we'll see how many kilowatt hours you use. Now what we try to do is we try to bring that demand down. So you can put technologies in like CFLs, you can put more installation in, you can put dimmer switches out there. So like in Alliance territory, when you apply for PV, they do an audit. They come out and do an audit. It costs about $100 as a homeowner, $250 as a commercial owner. And they'll go through all these, they'll audit your location. They'll give you these certain dynamics and certain options to lower your demand, and then they'll give you certain incentive levels. They have a standard level and they have an efficiency level. Well, if you do the efficiency measures, they're going to give you more dollar per kilowatt hour in your first year production. I'll kind of show you what that is. So you look at, so then you calculate your size of your system. You say, okay, I'm doing 15,000 kilowatt hours a year. My goal is to offset that, so it's a 10 kW. So you look at the 10,000 watt system at whatever your install cost is, $4, and then you kind of go through what your rebates are, what your incentives are, what your depreciation is, and then obviously you see the lifetime of that. And then you put in an inflation rate on energy, because energy gets more expensive every single year. So when you drop in about a 5% escalation rate on energy costs, these systems really start to pay themselves off pretty fast. So obviously return on investment, how much money you put in compared to how much money you pay now. So that solar is, you got to think of it as a investment and a financial decision. It's not really, like I said, about the technology. It's about what it costs me, how much I can offset, and what my return on my investment is. I mean, it's like a cash machine, basically, because you're putting it up there and sending power out to the grid every day, and it's great cash flow for it. I don't think we have to go through some other stuff. It's kind of redundant a little bit.
I'm just going to add, behaviorally, U.S. consumers, just ask yourself right now, everybody in this room, like, what things do I purchase, maybe on an annual basis or every 5 or 10 years, that I actually really stop and think, am I going to get my money out of this investment? Or is this something I really need for my home? Do I really need this car? And think about when you don't actually have the cash on hand or in the bank, you go to the bank and you ask them to lend you money, and what kinds of things are they more than willing, provided you have enough credit and, good standing, then yes, they'll back you. Well, they'll back you for, maybe a business loan. They'll back you for purchasing a building, a house or a business building. They'll back you for you start to get into the things like, well, I want to put